Welcome to a deep dive into, I guess you could say, the most fascinating machine that you possess your own mind.
That's a good way to put it.
We're going to be exploring excerpts from Steven Pinker's book, How the Mind Works.
Mm-hmm.
And we're going to uncover some really intricate design behind the everyday mental feats that you probably take for granted.
You know, it's true. We often underestimate the sheer complexity of our minds. We see, we walk, we make decisions, all seemingly effortless, but Pinker reveals the incredible, almost engineering behind these actions and debunks the myth that our minds operate as this singular, all-powerful force.
Yeah, and he uses a really cool analogy in the book. He compares our minds to machines.
Yeah.
Specifically, systems of organs of computation.
Right.
And I love that because it highlights how all these different mental processes work together like a well-oiled machine.
It is a powerful analogy, and it gets even more interesting when he compares the mind's versatility to something we use every day, the human hand.
Okay.
Think about it. One tool that can lift heavy objects, gently caress a loved one, or even play a complex musical instrument.
Wow. Yeah, I never thought about it that way.
Yeah.
Our hands are incredibly versatile, just like our minds.
Mm-hmm.
And speaking of versatility, Pinker emphasizes that our minds are products of millions of years of evolution shaped by natural selection to solve problems that our ancestors faced.
Exactly. Your mind isn't just a product of your personal experiences. It's also a product of your evolutionary history. And here's where it gets really mind-blowing. Pinker challenges the common assumption that selfish genes automatically lead to selfish behavior.
So you're telling me that my desire to help others, or even just be a decent person, could be influenced by my genes?
It's a fascinating possibility, isn't it? Sometimes the most advantageous thing a gene can do is to create a brain that's capable of cooperation, empathy, and even altruism.
Okay.
Think about it. Those behaviors can lead to stronger social bonds, which ultimately benefit survival and the propagation of those very genes.
Okay, that's starting to make sense.
Yeah.
But Pinker also cautions against overly simplistic evolutionary explanations for human behavior, right?
Yes, he does. He calls out those just so stories where people try to explain complex behaviors with these very superficial connections to our evolutionary past.
Right.
He uses a really clever example to illustrate this. Remember that National Lampoon cover with the puppy and the caption, "Buy this magazine or we'll shoot this dog."
Oh, yeah, I remember that dark humor, but I see where you're going with this.
Exactly. Pinker uses this example to illustrate the tension between understanding the cause of something and assigning moral responsibility. Sure, we might understand why that magazine cover was successful. It tapped into our evolved aversion to seeing harm come to cute animals.
Right.
But understanding that cause doesn't excuse the potentially manipulative tactics used to sell the magazine.
It's like saying, well, my genes maybe do it.
Right.
It raises all sorts of interesting questions about how we separate scientific explanations from moral judgment.
It does. It's a complex issue, especially when we consider sensitive topics like sexuality.
Right.
And that leads us to Pinker's discussion of the mind as a Turing machine.
Okay, a Turing machine, that sounds a bit technical. What exactly does that mean?
Well, think of it as a machine that can use simple rules and symbols to perform any computation imaginable.
Okay.
Pinker gives a really vivid example. A Turing machine made from dice rocks and toilet paper.
Dice rocks and toilet paper. That's a strange combination, but it definitely piques my curiosity.
It highlights the point that even seemingly simple materials can perform complex computations when organized in the right way.
Right.
And our brains do just that, using various formats to represent and process information. Visual images sounds grammar, and what Pinker calls mentalese, the language of thought.
It's fascinating how our brains use all these different ways to represent information.
It is.
And speaking of different representations, remember that research by Posner and his colleagues where people responded differently to the same letter depending on whether it was uppercase or lowercase?
Absolutely. That's compelling evidence for the existence of multiple mental representations at work within our minds. But even with all this complexity, Pinker acknowledges that there are limitations to certain models of the brain, such as neural networks.
Okay, limitations. How does he explain that?
Well, imagine a neural network trying to represent the sentence, "The baby ate the slug when the poodle ate the chicken."
Okay.
A simple neural network would struggle to accurately capture all the relationships in that sentence. Who ate what? When did they eat it?
Ah, I see. It's about accurately capturing the nuances and relationships between concepts, right?
Precisely. It suggests that our minds rely on more than just simple associations.
Right.
We need more structured representations to make sense of the world, which leads to another fascinating concept that Pinker explores the duality between fuzzy stereotypes and crisp categories.
Fuzzy stereotypes and crisp categories. Okay, you've got my attention. Tell me more about this.
Okay, so think about the word bachelor. The dictionary definition is pretty straightforward,
Yeah.
but does it really capture all the nuances of who we consider a bachelor? There are social context exceptions, gray areas that make it much more complex than a simple definition.
That's so true.
Yeah.
It makes you realize how much our thinking relies on both those fuzzy stereotypes
Right.
based on observations like, birds can fly, and those crisp categories with rules like the definition of bachelor. It's like our brains are constantly juggling both.
Exactly. And this interplay between fuzzy stereotypes and crisp categories applies to how we understand the world around us, especially when it comes to our visual perceptions.
Speaking of visual perception, Pinker delves into those mind-bending illusions that reveal how our brains construct our experience of the world, right?
He does. He starts by highlighting this fundamental challenge of vision, something engineers call inverse optics.
Inverse optics. Okay.
Essentially, it's the problem of figuring out what's actually out there in the 3D world based on this limited 2D information that our eyes receive.
So our eyes are basically taking a flat picture of a 3D world, and our brains have to figure out how to make sense of it. It sounds like a tough job.
It is. It's like trying to recreate a 3D puzzle from a 2D blueprint. To solve this inverse optics problem, our visual systems have evolved to rely on assumptions and shortcuts. These rules of thumb honed by evolution over millions of years.
So it's amazing to think that our brains are constantly making these educated guesses about the world based on these assumptions. Can you give an example?
Think about lighting.
Okay.
Our brains assume that lighting is usually uniform,
Right.
that a whole scene is either bathed in sunlight or shadow.
Mm-hmm.
But when that assumption is violated, like when someone's standing in the shade with a bright sky behind them, a camera might get fooled and turn them into a silhouette.
Ah, that explains those awkward vacation photos. But our brains usually compensate for those variations in lighting.
Exactly. We adjust our perception of lightness based on the surrounding context, factoring out the overall illumination to estimate the true color of a surface. It's not just about the raw data our eyes receive, it's about how our brains interpret that data based on pre-existing knowledge and expectations.
So it's like our brains are constantly running these background programs, using our past experiences to make sense of the present. And speaking of past experiences shaping perception, Pinker dives into those fascinating magic eye autostereograms. Those always fascinated me.
Right.
But I could never see the hidden image.
Those are a great example of how our brains can extract 3D depth information from these subtle differences and repeating patterns. It's a complex process that involves matching up corresponding points in the two images projected onto our retinas.
So our brains are basically doing a high-speed comparison, looking for tiny discrepancies to construct a sense of depth. That's amazing. Is this ability we have to perceive depth, is that something we're born with?
Interestingly, no, it develops gradually during infancy.
Wow.
And can actually be permanently damaged if one eye is deprived of input during those critical early years.
That's incredible. It highlights how crucial that early visual input is for developing our brain's ability to see the world in 3D. So we talked about lighting and depth, but what about recognizing objects? How does our brain go from a bunch of lines and colors to knowing that we're looking at a chair or a dog?
Well, Pinker explores this influential theory that suggests our brains use simple 3D shapes called genes as building blocks for object recognition.
Genes.
Okay. Think of it as a mental Lego set where each gene represents a basic geometric component.
I like that.
Like a cylinder, a cone, or a block.
So our brains break down complex objects into these simpler geon shapes. It's like our brains are doing geometry without us even realizing it.
Exactly. And the key insight here is that these genes are viewpoint invariant.
Okay.
Meaning they can be recognized from almost any angle. Think about a coffee mug. You can instantly recognize it whether you're looking at it from the side above or even upside down.
Yeah, that makes so much sense. It's not about matching a specific image in our memory, but about recognizing the underlying structure our brains are incredibly efficient.
That's the beauty of the genome theory.
Yeah.
Of course, it's not perfect. Some objects, like trees or mountains, have complex shapes that don't fit neatly into those JANA categories.
Right.
But for many everyday objects, this theory captures a lot of what's happening in our brains.
So our brains are these amazing machines running these efficient algorithms to make sense of the world.
Sure.
But Pinker also talks about how those same algorithms can sometimes lead us astray, right? Like with visual illusions.
Yeah, he uses fascinating examples like the Ames room,
Okay.
a distorted room that plays tricks on our perception of size,
Mm.
and the Adelson-Checker shadow illusion, where two squares that look like different shades of gray are actually the same color.
Oh, yeah.
These illusions reveal the assumptions our visual system makes about lighting depth and even motion.
Those illusions are so mind-bending. It makes you realize how much of what we see is our brains constructing a model of the world, not just passively taking in information.
Exactly. That model is constantly being updated and refined based on new information and experiences. It's a dynamic process, always evolving.
But if our visual systems are so prone to illusions, how can we be sure we're ever seeing the world accurately? It's a bit unsettling to think that our brains can be so easily tricked.
It's a great question, and Pinker addresses it head on. He argues that while our visual system isn't perfect, it's incredibly well designed for the kinds of problems our ancestors faced.
Okay.
Navigating their environment, recognizing food, and predators interacting with others.
That's about being ecologically rational.
Yes.
Our visual system is optimized for the specific challenges of our evolutionary niche, not for some abstract notion of perfect perception.
Exactly. And within that niche, our visual system is incredibly powerful.
Yeah.
It allows us to see in 3D, recognize objects, perceive motion, and extract meaning from complex visual scenes.
Wow.
But Pinker also explores the subjective side of seeing,
Okay.
the feeling of actually seeing something, the qualia of color and shape.
It's like that age-old question. If a tree falls in the forest and no one's around to hear it, does it make a sound? We know our brains process visual information, but what about the subjective experience of actually seeing red or seeing a square?
That's the essence of the hard problem of consciousness.
Right.
How can we explain the subjective experience of redness, for example, purely in terms of neural activity and computations?
It's almost like there's this gap between the objective scientific description of what's happening in the brain and the subjective experience of what it feels like to actually see something.
Pinker acknowledges this mystery, admitting that even a complete understanding of the brain's workings doesn't fully address that subjective feeling of seeing.
So while we're making great strides in understanding how the brain processes visual information, the subjective experience of consciousness remains a bit of a mystery. It's like we've mapped the terrain, but we haven't quite grasped the essence of what it feels like to stand on that ground.
That's the current state of things.
Right.
But Pinker offers some intriguing ideas about the role of consciousness, suggesting it might be connected to our ability to access and report on certain information in our brains.
So consciousness might be less about some mysterious inner essence and more about a specific type of information processing, a way of bringing certain mental contents to the forefront of our awareness.
That's one of the possibilities Pinker puts forward. He also connects this idea to our sense of self, our ability to reflect on our own thoughts and experiences.
So we've come a long way, from the mechanics of vision to the mysteries of consciousness. It's incredible to think about all the complex processes happening in our brains every time we simply open our eyes and look at the world.
It is, and this exploration of visual perception is just one piece of the puzzle.
Right.
Pinker goes on to discuss the evolution of intelligence, exploring how even simple creatures display remarkable cognitive abilities and what makes human intelligence so unique. Ready to dive into that?
I'm ready for more. When we talk about intelligence, we often think about human intelligence. I'm ready for more. When we talk about intelligence, we often think about human intelligence. But Pinker argues that even simple creatures can display remarkable cognitive abilities.
It really is.
It's mind-blowing to think about how evolution has shaped these abilities.
Remember those desert ants we talked about earlier?
Yeah.
They use dead reckoning to navigate, essentially performing calculations to find their way back to their nests.
It's like those ants have a built-in GPS. I mean, how can something so small have such sophisticated navigational abilities?
Yeah.
It really makes you wonder what other incredible cognitive feats are happening in the animal world, right?
Absolutely. It speaks to the incredible power of natural selection to optimize organisms for their specific environments. But Pinker also dives into what makes human intelligence unique, introducing the concept of the cognitive niche.
Okay, so what exactly is this cognitive niche? What sets humans apart from other intelligent creatures?
Pinker suggests that humans have evolved this unique set of cognitive abilities that allowed us to occupy this special place in the ecological landscape.
Hmm.
Think about abstract thought language tool use and social cooperation, all working together to create this powerful engine for problem solving.
So it's not just about having a bigger brain. It's about how that brain is wired and the specific cognitive tools it has access to. It's like having a toolbox full of specialized gadgets.
Precisely. And those tools were likely shaped by the specific challenges our ancestors faced, like the need to hunt, gather, build shelters, and navigate complex social relationships.
It's amazing how those evolutionary pressures might have driven the development of language, abstract reasoning, and even our capacity for creativity. But I've always wondered if basic survival was the driving force. Why did humans develop such advanced intelligence, it seems like overkill, for just surviving in the savannah?
You've hit on a question that puzzled even Alfred Russel Wallace, who, along with Darwin, co-discovered the theory of evolution by natural selection. He wondered why human intelligence seemed far more advanced than what would be necessary for mere survival.
So how does Pinker address this apparent paradox?
He argues that those ancient environments provided a foundation for the development of our modern cognitive abilities. The seeds of language technology and even art were sown in those early hunter-gatherer societies. He even suggests that seemingly useless abilities like music or humor might have played a role in social bonding mate selection or even cognitive development.
So it wasn't just about surviving in the moment, but about thriving in a complex social world and passing those advantages down to future generations, music and humor as evolutionary advantages. It's a really fascinating idea.
And as those cognitive abilities evolved, they created a kind of feedback loop, leading to even more complex social structures, technologies, and cultural innovations, all contributing to what we now call human civilization.
It's a truly awe-inspiring story, and Pinker's insights into our minds help us appreciate the incredible journey that brought us to where we are today. But as we've discussed, even with these amazing cognitive abilities, we're not always perfect logicians. We make mistakes, fall prey to biases, and sometimes make irrational decisions.
It's true, if our minds are so well designed for solving problems, why do we still make so many errors? Why are we susceptible to those cognitive biases and illogical leaps in thinking? It's a great question to ponder. Perhaps the answer lies in the nature of our evolutionary history. Those shortcuts and heuristics that helped our ancestors survive might not always serve us well in the complex modern world.
It's a humbling reminder that our minds, while marvels of biological engineering, are still works in progress, and understanding their strengths and weaknesses is crucial for navigating the challenges we face in our everyday lives.
Absolutely. We encourage you, dear listener, to continue exploring the fascinating world of cognitive science, armed with the insights we've shared from Pinker's remarkable book. Discover more about the intricate machinery of your own mind, and perhaps you'll uncover those hidden biases and mental shortcuts that influence your thoughts and decisions.
It's been an incredible journey into the mind, and we hope you've enjoyed this deep dive. Until next time, keep those brains buzzing and those neurons firing.